Hello students, in the last lecture I started 8086 pin configuration and I discussed about the common signals of 8086 pin configuration that are used in both minimum as well as in maximum mode. So I discussed all the common pins. Just one pin was remaining and that was BHE bar. So before discussing BHE bar pin, let me discuss physical memory organization which is needed for understanding the BHE bar pin. So most of the memory ICs are byte oriented. That is, each memory location can store only 1 byte of data. The 8086, as we know, is a 16-bit microprocessor and it can transfer 16-bit data. So in addition to byte, word, that is 16 bits, has to be stored in the memory. This is stored by using two consecutive memory locations, one for least significant byte and other for most significant byte. The address of word is the address of least significant byte. To implement this, the entire memory is divided into two memory banks, bank 0 and bank 1. So as you can see, this CS bar is representing chip select. CS bar is representing chip select, means when this bank is going to get activated. So bank 0 is selected or bank 0 is activated when CS bar is equal to 0, and when CS bar is equal to 0 means A0 is equal to 0. So we can say that bank 0 is selected only when A0 is 0. Similarly, bank 1 is activated or selected when CS bar is 0, and when CS bar is 0 means BHE bar is 0. So bank 1 is selected only when BHE bar is 0. So I've already told you when I was discussing the pin configuration or 8086 microprocessor architecture or features, I told you that the address bus of 8086 microprocessor is of 20 bits, that is A0 to A19. So the address bus of 8086 microprocessor is of 20 bits. So the A0 that I am talking about is actually this A0, that is the lowest bit of this address, of the address carried by the 8086 microprocessor. So A0 is equal to 0 means it is for all even addresses. A0 is 0 for all even addresses. As you can see from this diagram also, if A0 is 0, the address can either be 00000, means the last nibble will be either 0, 2, then 4, just it will be the even. So the whole address will be even whenever A0 is 0. So bank 0 is usually referred as even addressed memory, and BHE bar is used to access higher order memory bank, that is bank 1, which is referred to as odd addressed memory bank. As you can see, these are all odd addressed memory banks. The last one is 1, 3, 5, 7 in this way. So together BHE bar and A0 decides whether a byte or word is to be transferred from or to memory locations. That is, depending on the status of BHE bar and A0, we'll get to know that whether a byte is going to get transferred from the memory location or to the memory location, or a word is going to get transferred from the memory location or to the memory location. So these are the statuses. So what happens when both BHE bar and A0 is 0, means both the banks are activated, which means the whole word is going to get transferred, and for data lines that are going to be used for transferring the 16-bit data is D0 to D15, and the address that will be carried by the address bus, as I have told you, it will be the address of least significant byte. So the address of word is the address of least significant byte. Again I am repeating, whenever BHE bar and A naught both are 0 means both the banks are activated. Here you can see both the banks are activated means the whole word, that is whole 16 bits, is going to get transferred to the memory or from the memory. So the data lines activated will be D0 to D15, and the address will be the address of the least significant byte which the address bus is going to carry. Similarly, as you can see, when BHE bar is 0 and A0 is 1, BHE bar 0 means bank 1 is activated, A0 1 means bank 0 is not activated. So upper byte, the data lines that are going to get activated is D8 to D15, that is upper byte is going to get transferred from or to the memory, so to the odd address memory bank. Similarly, when BHE bar is 1 and A0 is 0 means bank 0 is activated and bank 1 is deactivated, which means lower byte is going to get transferred from or to the even addressed memory bank, that is bank 0. Even addressed memory bank means bank 0, odd addressed memory bank means bank 1. And the data lines that are going to get activated, they are D8 to D0 to D7, as you can see from here also. So for bank 0, data is going to get transferred through D0 to D7, that is lower byte, and D8 to D15 will come to the bank 1, that is higher byte. So whenever bank 0 is activated means data lines activated will be D0 to D7, and whenever bank 1 is activated, data lines activated will be D8 to D15. And when both BHE bar and A0 are 1 1 means both the banks are deactivated, so no transfer is going to take place. So this was the last common pin that is being used in both the minimum and maximum mode of the 8086 microprocessor. Now next I am going to discuss about the minimum mode pins. Now we are going to specifically discuss about the minimum mode pins. As you can see, the minimum mode pins are INTA bar, ALE, DEN bar, DT by R bar, M by IO slash M by M slash IO bar, WR bar, HLDA, HOLD, then MN by MX bar. So one thing I would like to discuss here is sorry, I have mistakenly used VCC here. There is no VCC. 33 pin is for MN by MX bar. And one more thing, whenever I am discussing the pin configuration, or whenever you will be writing the pin configuration either for 8085 or 8086 microprocessor or for any microprocessor, be very specific with the pins. As I have shown you that INTA bar pin is at pin number 24 means INTA bar pin is at pin number 24. You cannot switch the position of INTA bar, because the whole 8086 microprocessor has been manufactured in such a way that pin number 24 is for INTA bar. So you have to be specific with the pin numbers. Okay, so starting with the minimum mode signal. So first is HOLD. That is HOLD or HLDA, that is the input output pin. A high on hold pin indicates that another master, that is direct memory access controller, is requesting to take over the system bus. On receiving hold signal, microprocessor outputs HLDA signal high as an acknowledgement. At the same time, microprocessor tri-states the system bus. A low on hold gives the system bus control back to the microprocessor, and the microprocessor then outputs low signal on HLDA pin. So here I have written type I/O, means I is for input and O is for output. So HOLD is a type I pin, means it's a input pin, and HLDA is type O pin, that is the output pin, means hold any signal is going to get inside the microprocessor through the input pin, and any status or any signal is going to out from the microprocessor through the output pin. So HLDA is output pin and HOLD is input pin. In the previous lecture also, when I was discussing about the common mode signals, here there also I've written that whatever. So okay, you can see the pin configuration. Wherever the arrow is this, it means bidirectional pin. Either the data can be either the data can go inside the microprocessor, or the data can come out of the microprocessor. So this is the sign of bidirectional pin. Then you can see these are the signs. Sorry, these are the bidirectional. Okay, then you can see these are the signs. As address data bus is a bidirectional pin, and then here address is a unidirectional pin, because only microprocessor is going to send the address. No address will come into the microprocessor, so it is a unidirectional pin and the direction is outwards. So you also have to be very specific with the direction of the pins also. If it is this means the pin is bidirectional, that is data can go inside the microprocessor or come out of the microprocessor. If the direction of the pin is outwards, means the data will come out of the microprocessor, and if the direction of the pin is towards the microprocessor, means any data, means the signal will go inside the microprocessor through that pin. So yes, the first pin of minimum mode I discussed, that is HOLD and HLDA. The next pin is WR bar pin. As we all know, WR bar, whenever WR bar pin is low, it means the 8086 is writing data into the memory or an input output device. So WR bar is low means WR bar pin is activated, and it means 8086 is writing data into the memory or input output device. So obviously it is a type O pin, that is output type pin, means it is like a status pin that the microprocessor is going to give the status through this pin, that it is writing the data. So we'll continue with the minimum mode pins in my next lecture also. I'm ending this class here. Thank you.